Hello, today we're going to go over our first section in chapter 4. This one is going to be on isosceles and equilateral triangles. So our objective for today, we are going to be applying the base angle theorem to set up an equation with congruent parts, and then we'll use that to solve. So the first thing we're going to go over is isosceles triangles. So we should already know that there are two congruent sides in an isosceles triangle. And in the isosceles triangle, the two congruent sides are called the legs. And then we also have two base angles. The base angles are going to be the angles that are opposite of the legs, so they're across from those legs. That is what the base angles are. That is still true even if our triangle is drawn a different direction. So say it was drawn like this, upside down. These are still going to be our legs. The base angles are still going to be these bottom two angles. I guess they're the top two angles in this triangle. Even though that they're not on the bottom, those are still the base angles because they're across from the legs. Then at the very top of our triangle, we have our vertex angle. And the base is always across from that vertex angle. So this one would be our base in this upside down triangle. And at the top, that is our vertex angle. So it doesn't matter what direction our triangle is drawn. Those are where the parts would be in an isosceles triangle. So we have what is called the base angle theorem. And what this is if two sides of a triangle are congruent, so you can add that in, then the angles opposite them are congruent as well. So in our example, if AB is congruent to AC, and they already have that marked in our triangle for us, then angle B is going to be congruent to angle C. And this is always true in an isosceles triangle, which is why we have what is called the base angle theorem. We also have what is called the converse of base angle theorem. This one is if two angles of a triangle are congruent, then the sides opposite them are also congruent. In the triangle they gave us, if angle B is congruent to angle C, then we know AB is congruent to AC. So this rule and this property of isosceles triangles is going to help us when we're solving for different values. Let's look at our first example. Angle E is equal to 2x plus 40, so I'm going to go ahead and write that in there. We have this 2x plus 40. And angle F is 3x plus 22. They want us to find the measure of each angle. So the first thing we're going to do is we're going to look at what we know. And we know that ED is congruent to FD, which, because of our converse base angle theorem, we know that those base angles are going to be congruent. So we know angle E is congruent to angle F. Now that we know this information, we can set up an equation to solve for x. Angle E was 2x plus 40, and we know that is going to be equal to 3x plus 22. Then we're going to go ahead and solve. First thing I'm going to do is subtract 2x on both sides. And then we are left with 40 equals x plus 22. Then to get x by itself, we're going to subtract 22 on both sides. When we do that, we are going to be left with x equals 18. Then we need to go back and read the question. This one they wanted us to find the measure of each angle. So there are three angles here that we need to find the measure of. we can use this 18 to find the measure of angle E. So we know angle E is equal to 2 times 18 plus 40. 2 times 18 is 36 plus 40, which is going to equal 76. I'm just going to erase this. So there's room for 76 degrees. Because we know angle E and angle F are congruent, we also know that angle F would be 76 degrees. One way that you could check your work to make sure you did this correctly is to plug 18 into that equation as well, just to make sure that we get the same answers. And we would get 54 plus 22, which would equal 76 as well. So that means we do have the correct answer for X. Then our last thing, just like we did last chapter when we were finding the third angle in a triangle, we will add the two angles we know together, 76 plus 76. We will get 152. And then we're going to subtract that from 180 degrees. And that will give us our last angle measurement that we need, which would be 28. And that would be our answer for this problem, finding the measurement of each angle. All right, our next example. They want us to find the value of X. So in this one, we know that we have two congruent sides. So that tells us that the base angles are going to be congruent. So if this one is X down here, this angle up here is also going to be X degrees. And we know that this angle here is 90 degrees. If we set up our equation, we know 180 is equal to 90 plus X plus X. We could simplify by combining any like terms. X plus X is equal to 2X. Then we can go ahead and solve. We can subtract 90 on both sides, and we would be left with 90 equals 2X. Anytime that we have a right angle in our triangle, the other two angles are going to be complementary to each other. So if you wanted to, if you remember this, you can skip this first part of this work process, and you could just start with 90 equals 2X. Because we know that they're complementary, so we know their sum is going to add up to 90. Then the last thing we can do is divide by 2, and we would get 45 degrees equals X, which is our final answer because this one just asked us for the value of X. Okay. Our next example, we have another isosceles triangle, and we are asked to find the value of X. Because this is an isosceles triangle, we know these two base angles are going to be congruent as well. Because this bottom one is 3x plus 8, that means this angle over here is also going to be 3x plus 8. So take a minute, pause the video, try to set up an equation for this and solve for X. Once you have your answer, press play to see if you got it correct. The way that I would solve this one, we have three angles, so I'm going to add them all together. 3x plus 8 plus 3x plus 8 plus 2x plus 20. And because these are three angles in a triangle, I know they all add up to 180. Then I would combine like terms. We have a total of 8 x's. And then we have 8 plus 8, which is 16, plus 20, which is going to be 36. That is equal to 180. Then to solve, subtract 36 from both sides. And we get 8x equals, do a little borrowing. That would be 4. Then we divide by 8. Oh, 144. Then we get x equals, let's do 144 divided by 8. Goes in there once. And 8, because 8 times 8 is 64. So our answer is x equals 18. And again, if you wanted to check your work, you can plug x in to the different expressions to make sure that they all add up to 180. Okay, the last thing we're going to go over today is the corollary to the base angle theorem, which tells us if a triangle is an equilateral, then it is also going to be equal angular. This also means if a triangle is equal angular, then it is equilateral. So anytime you are given 3 congruent angles, you know all 3 sides are also congruent. If you're given 3 congruent sides, then we know all 3 angles are congruent. So if we look at this example 4, we're going to find the measure of R, S, and T. If you notice right away, all 3 side lengths are equal to 3 meters, which tells us all 3 angles are equal to each other. Now, if you don't know what they equal, we are going to go through this and solve. So if this one is equal to x degrees, all 3 of them would be equal to x degrees. If we set up our equation, we would have x plus x plus x equals 180. If we combine our like terms, we get 3x equals 180, and then we would divide by 3, which tells us x equals 60. Every time you have an equilateral triangle, all 3 angles are going to be equal to 60 degrees, because no matter how many times we divide 180 by 3, it is still going to be equal to 60. So we know that the measure of angle R equals 60, the measure of angle S equals 60, and the measure of angle T equals 60. And that would be our final answer. Next, we are given an equal angular triangle. So right away, we should know that this is also equilateral, telling us that all 3 sides are congruent. This side is equal to 6, this side is equal to x. We would set up our equation, x is equal to 6. Even if we were given an expression saying 6x minus, we'll do plus 12, then we would just say 6x plus 12 equals 6, and you would go ahead and solve. So even if you are given longer expressions in these problems, you would still set it up the same way, just putting them equal to each other. And that is our last example for today. There is a homework assignment posted. It is labeled as 4.1 homework. Complete the ones that are on there, and then tomorrow, hopefully I will be back and we will go over those together. Have a great day.